Right, we're looking at the chain rule here, and actually I'm going to do the one on the right first. I'll do it in green. Okay, so I'm going to do this one first, purely because I've got y equals 5 plus x squared to the 3 over 2. Okay, do it right with one of these pens on the board. So what I'm going to do is I'm going to say, well, u equals 5 plus x squared. Alright, that's the first thing I'm going to do. I'm going to say, well, du dx equals 2x. Alright, so I've just differentiated that. Now, I also know that y now equals u to the 3 over 2. So dy du equals 3 over 2 u to the half. Alright, now that's all basic differentiation. All I've done is swap in u for this whole thing here. Alright, in fact I'll use a different colour. I'll just go rub that out and then go back to my pen. And so for this I've used the u here. Alright, so that's where that's come from. Now then, the chain rule says that dy dx, and this will look fairly obvious, is dy du times du dx, and you'll notice the du's cancel. Okay, so all I've got to do now is write dy du, so dy du is 3 over 2, and I know that u is 5 plus x squared, alright, to the power of half, and I multiply that by du dx, which is 2x. Take that and simplify, so actually the 2's cancel, we just get 3x 5 plus x squared to the power of half. Okay, so that's that. Now, what I've got over on the first one is two different chain rules. Okay, so if I'm going to say, now this might be a bit confusing, but I can't think of a better way of doing this, but if I say that y equals e to the 3x, that should be a 3 there, not very well done. I'm going to say u equals 3x, so, oh jeepers, there we go, du dx equals 3, right, and I've got y equals e to the u, and so dy du equals e to the u, and so therefore, and I'll do it in a little box here, and hopefully I'll be able to fit it in, dy dx for this bit, alright, in red, is going to be dy du times du dx, so I'm going to get 3e to the 3x. Alright, and that should show you where the differentials for these come from. Now, going to the red, I know I'm using y again, for anyone moans. I'm going to say y equals ln 2x. I'll call it v this time. V equals 2x. So dv dx equals 2. Alright, y equals ln of v. So dv equals 1 over v. Right, and again in my little box here, dy dx then is going to be dy dv, which is 1 over, hold on, where are we? Where is v? 1 over 2x, so I'm going to get 2 times 1 over 2x, which equals 1 over x, and you should recognise that. Now then, if I combine all of them, let's see, I'll do it in black here. So dy dx of the whole thing. Alright, and I've run out of box. Crumbs, take ages. Like I say, when you get used to this, you won't need quite so much room. You'll know these. So I need to combine the two. I've got 3e to the 3x plus 1 over x. Alright, so I've just split it up into two, but again, like I say, when you get better at this, you'll be able to do this without using the chain rule. I'm just showing you where the chain rule comes from. It's more like this sort of one here on the right hand side, where you kind of do need to use a chain rule, but again, you'll start to recognise how it works and be able to do it without the chain rule. But what you're doing in your head is chain rule.